welcome friends to the last segment of this machining lecture. In this lecture, we will primarily focus only on grinding operation. The two lectures, whatever we saw, a single point cutting tool, a multiple point cutting tool. So, here now the cutting tool is reduced into a powder. Now, once it is reduced into a powder, now what happens to the geometry? How do you decide the geometry? So, that is what we are going to see in this lecture. And there was a question which was asked by some of the students saying that, sir, what happens to the geometry which is there in milling as compared to that of turning? Turning, you said you have 6 angles in a solid tool, 6 angles and 1 nose radius. Almost all the things are there in milling also. When we have a cutter and when we try to take a cross section of the cutter, you will try to see a teeth. You will try to see a teeth. In that teeth, if you try to further do a cross section of it and see, you will see clearance angle, relief angle, flank, everything there. So, that is why I did not go deeper into it, but friends, you should keep this in mind. Here also you have positive rake, negative rake, everything. Now, getting into this lecture, we will try to see abrasive machining, then we will try to see grinding, grinding wheel, dressing, then we will try to see some of the abrasive materials and grinding process. Finally, we will try to have a recap. Abrasive machine, here the material is removed by the action of hard abrasive particles. Usually, these abrasive particles are bonded into a wheel. So, they are, since they are small cutting tool and they are all bonded, the amount of material which is removed is going to be very less. So, if it is going to be very less, generally we use these operations for finishing operations, where major chip is removed and small asperities on the surface are removed by grinding. Grinding is a very important process, and like the grinding, we also have other processes like honing, lapping, super finishing, polishing and buffing. All these things are almost the same. The only difference can be the abrasives are loosely held or the abrasives are rigidly held. Why abrasive process are very important? Because it can be used to remove all types of material. You can also remove ceramic, you can remove metal, to some extent you can also remove polymer you want. So, the finish whatever you get, you can go up to 1 micro inch or it is 25 microns you can go. So, here if you see, this is a cutter, an abrasive, this is like a cutter, and between cutting edges you see a small chip getting formed. It is very similar to that of milling. The only difference is the cutter size is small, and then the cutter size is random. You can see here there is a star, there is a single point cutting tool, then there is a flat portion, then you have another thing. So, this is the difference. Irregular tool geometry and the tool cutter is very small. They are all held together by a paste. They form a wheel. So, that process is called as grinding. So, material removal process in which abrasive particles are contained in a bonded grinding wheel that operates at a very high cutting speed. Why very high cutting speed? Because the chip size is very small. So, the tool contact is going to be very small. So, if it is very small and if you go very slow, it will take long time to finish and there will be a lot of rubbing action. So, we try to move it at very high speed such that it can be removed, and here the chip size is very small. So, if you look as such into abrasive grinding or an abrasive, this is the grain size. You will try to, when it tries to come in contact, it will try to remove material in the form of chip. So, the sharp portion gets broken and then you get a wear flat. Same phenomena is there. When the chip is formed, you have a shear angle, and this is the cutting velocity. The workpiece can move or the grinding wheel can move. The grinding wheel can also go at very high speeds, right. So, if you look into it, majority of the time from the force plot and other things, we find out that the rake angle will always be negative in grinding or with respect to abrasive. So, if it is negative, then the forces are very high. Once the forces are very high, the power is very high. So, the cutting, if the energy used for grinding will always be very high. So, they are used for finishing ceramics and glass, they are used for finishing metal, structural shapes, masonries, concretes. They are also used to remove unwanted weld beads and spatter. They are used for clearing the jet of air or the water containing with the abrasives. So, this is how a typical grinding wheel looks like. This grinding wheel is mounted onto a grinding machine, and the grinding machine is horizontal. It is almost like your milling machine horizontal. So, here the thickness is not very large. So, we do not have an overarm to support generally. You have it short and slender. So, it is mounted directly to a spindle. So, now the question comes is, how do you specify the grinding wheel? So, we specify the grinding wheel with the following parameters. What is the type of grinding abrasive material I use? What is its size? What is the bonding material which is used? What is the wheel grade? Wheel grade is whether the abrasives are tightly packed or whether it is loosely packed. Then we will try to look into the wheel structure. So, abrasives, there are several different types of abrasives. The grain size, we always sieve it and find out. Bonding is what is the material used to bind. So, this is how a typical specification of a grinding wheel looks like. This talks about the abrasive. If it comes with a letter A, then it represents alumina. If it comes with a letter C, it represents silicon carbide. The 36 talks about the abrasive grain size. If it is coarse, it is 8, 10, 12. If it is medium, it goes up to 60. Anything above 60 goes to fine. Very fine is also there. What happens when the grain size is very small? The chip size is very small. So, the amount of material removed is very small, but you can precisely remove material. What is the grade? The grade is whether the material, the wheel is made out of material which is soft, medium and hard. If it is soft, what happens? As and when there is maximum load while cutting is given by the abrasive tries to resist the workpiece material to form a chip. Suppose if the force is too high, then immediately what happens? The abrasive breaks or the abrasive falls out of the binding. If it does not do that, it is going to create a scratch. So, only for that what we do is we try to choose binding material which is soft or hard, whatever it is. So, the grade talks about how is the binding there so that it can be eased out. The structure is, it talks about whether it is closely packed or loosely packed or far away packed. So, densely packed and it is open packed. So, open packed means it can accommodate more chip. Then V tries to talk about the bonding material. So, here friends, understand these two are very important properties. Type of abrasive, grain size and bond, clearly understood. The grade, whether the wheel is soft, for glass machining it can be hard. For normal steel machining it can be soft or medium. The structure is the openness of the between the abrasive, what is the size. So, here also we talk about the three important properties: hot hardness, then wear resistance and toughness. So, this is the grain, this is the pore, this is the bonding material. The pore will lead to structure. So, friability, the capacity to fracture when cutting edge dulls. So, a sharp cutting edge comes into action. So, a sharp edge will try to fracture. So, now what happens? You have two cutting edges, right? It randomly breaks. So, you will have many cutting edges. Friability is the place when it is fracturing. Then abrasive workpiece material is compact. Abrasive workpiece material compatibility is also very important. The affinity of the abrasive grain to the workpiece is important. So, it should not diffuse any material from the abrasive gets into it. So, for example, the abrasive should not dig and go stay there. So, hardness combination is also very important. It should be less reactive, because here is going to be a very high temperature. The bond material should not get diffused into the workpiece. So, typically alumina is used, SiC is used, CBN can also be used, diamond can also be used. You should go back and correlate this with respect to different cutting tool materials we saw: HSS, tungsten carbide, coated carbide, CBN, artificial that is diamond, artificial diamond also we saw. So, here also we have alumina, silicon carbide, cubic boron nitride, etc., etc. So, the hardness is given very clearly. Diamond has the highest hardness as compared to that of abrasives. So, grain size I have already discussed. Smaller grit size produces better surface finish. Larger grit size, the amount of material removal is there. So, larger grit size, it can shear, create new cutting to edges while machining. In small, it is not possible. Soft materials require larger grit size. The grain size we have already discussed. So, I am just going through it. So, bonds, vitrified bond, resinoid bond, reinforced wheel bond, thermoplastic, rubber, all are used. So, consist of feldspar and clay is vitrified bond. Resinoid bond is bond material with thermoset resin. You also have rubber like, because these cutters are soft and they can try to take little bit of flexibility. Thermoplastic is also used as a binder, which we generate sol gel abrasive bonding with thermoplast is also used. Reinforcement, the layer of glass fiber mat of various mesh size are used for reinforcement. So, all these things play an important role for holding the workpiece. So, the wheel structure I have already discussed. Some of the standard grinding wheel shapes, straight it can be there. Then you can have two-sided recess, these are two-sided recess. Then metal wheel frame with abrasives. These, so here like in insert, the other portion can be made out of metal and then we apply a bond here. We have like an abrasive stick which is stuck on both sides. That is also possible. You can have thin disc like sawing operation. You can also have abrasive cutters, slitting operation it does. So, the general mechanism in grinding is going to be three. One is cutting mechanism, ploughing mechanism and then rubbing mechanism. In cutting mechanism, the abrasive tries to come in contact with the workpiece and then it tries to remove a chip. So, that is called as cutting. In ploughing operation, there is force, the workpiece assuming it is soft. So, now the abrasive digs inside and the material is ploughed, it is not removed, it is only displaced, it is not removed. In rubbing action, there is no cutting, the edge of the abrasive is blunt, it does not cut, it just scrapes through, it rubs. Okay. So, this rubbing action is giving you lot of heat. So, this heat will try to distort the workpiece property. So, these are the three typical mechanisms: cutting mechanism, ploughing mechanism and rubbing mechanism. In ploughing and rubbing, the material is not removed, it is only displaced. In rubbing, nothing happens. So, the grain fracture, as I told you, as and see, if you see one abrasive, the other abrasive, they are bonded together by the bonding bridge. This bonding bridge is the material what we discussed here. Okay. And depending upon the force what is there while cutting, so what happens is the abrasives can fracture. So, this fracturing only we learnt it as friability property, with the capacity to fracture when the cutting edge dulls. So, this is what we are trying to see, and here you can see while grinding operation happens, the abrasives can fracture half, it can fracture small, so that the fresh cutting edges come into action for removing material. So, there can be a small fracture of a grain, there can be half fracture of a grain, there can be a bond fracture alone. The bond should also be in such a way such that if there is lot of resistance coming to the abrasive grain, then the easiest way should be the bond should fracture, so that the fresh grain comes in contact, fresh abrasive comes in contact for machining. So, there can be a bond fracture, there can be a micro fracture, there can be a grain fracture. So, the cause of the wheel wear like atresia wear and bond fracture. Atresia wear are dulling of individual grains resulting in a flat spot and rounded off edge, analogous to tool wear whatever we have seen in the past. So, bond fracture also we have discussed. So, there is like we have cutting chip thickness ratio, in grinding we have grinding ratio. Grinding ratio is the volume of material which is removed from the workpiece divided by the volume of abrasive grains removed or worn out. So, that is called as GR, grinding ratio. So, generally we find out the grinding ratio and see the compatibility between the workpiece and the cutter. So, when the grinding wheel gets lot of dull abrasives, flat abrasives, we have to remove them. So, that operation is called as dressing. Dressing is accomplished by rotating a disc abrasive stick or another grinding wheel held against a wheel being dressed as it rotates. The function is to remove all the dull grits, and it also tries to remove the chip clogging what happens. So, after a few grinding strokes, we always do a dressing to get the fresh edges to sharp edges to come in contact. There is also another operation called as truing. Truing is trying to give a shape to the grinding wheel such that the profiles can be maintained. Use of a diamond point tool fed slowly and precisely across the wheel as it rotates. A very light depth is done against the grinding wheel, not only sharpen the wheel, but also restores the cylindrical shape, ensuring straightness around the outside perimeter. So, that is truing. There are different types of grinding. So, we will see them like milling, you had different types, turning, you had different types. In the same way, you have grinding also different types. So, surface grinding is one of the type. You can have horizontal, you can have vertical. You can have rotating the horizontal spindle where the table can be reciprocating, where the table can be rotating. So, in both the cases, these are reciprocating type, these two are reciprocating, these two are rotating. Okay. You can have it horizontal, you can have it vertical. So, this is surface grinding. The surface of the grinding wheel is used to grind the workpiece. So, here the periphery is used, the difference is only rotation, reciprocation, rotation, face, reciprocation, rotation. This is surface grinding. So, this is mounted onto a machine tool which is called as surface grinding machine. So, again the same way like what you have in milling machine, you also have it here. You also have cylindrical grinding. Cylindrical grinding means where the part what you produce can be externally cylindrical or internally cylindrical. Here the spindle is mounted horizontal and the grinding wheel is rotated as against the workpiece. So, you can get stepped shaft where in which you can grind, internal you can grind. So, those things are called as cylindrical grinding. So, here the first one was surface, flat, and here it is cylindrical. The next one is centerless grinding is used. In centerless grinding, wherever you have a long lengthy workpiece where the diameter is small, length is long, you cannot hold it between headstock and tailstock. So, here what we do is we do centerless grinding operation. So, here like in cylindrical grinding, the grinding wheel rotates at an RPM, then you have the workpiece which is there, then we support the workpiece through a regulating wheel. The regulating wheel will always be at an angle such that it tries to bite and pull the material inside, the workpiece inside, grinds and it throws out. So, like a shaft, you can small shafts you can try to do, like this shafts can be easily ground cylindrical by using a centerless grinding machine. So, you will have a grinding wheel, you will have a support which supports the workpiece and then which regulates and pulls the workpiece is done by a regulating wheel. It is always made out of rubber, it only gives friction. The workpiece is supported at the rest blade. So, you also have creep feed grinding. Creep feed grinding have a very high depth of cut with a very low feed rates, it is called as creep feed grinding. The depth can be 1000 times to 10,000 times greater than the conventional machining. It is almost like a milling operation, creep feed grinding. The feeds are very slow, the depths are very large. So, this is how a creep feed grinding is done. So, in feed is this much. So, the material to be removed is this. So, here this is the conventional way of doing it. In creep feed grinding, we do the depth in one shot. So, naturally the grinding wheel should be harder, the abrasive should be better, all these comparisons are there. From the grinding, there are some small extrapolations of grinding. Honing is an operation wherein which the grinding wheel, whatever I said, is converted into a abrasive stick. So, these abrasive sticks are placed peripheral to the tool. The tool rotates and reciprocates, and as and when it rotates and reciprocates, it also expands. So, honing is an operation where you have a cylindrical hole, you want to expand like reaming you did. Here you can expand the hole, and inside the hole you can create crisscross hatch patterns. Why is this important? This is important because when you are trying to do a lubrication action between piston and the cylinder, these diamond like points, these are called as pinch points, where the oil can be retained and it can help in lubrication. So, honing can be done internal, honing can be done external. So, here it is a grinding wheel is cut into strips. These strips are located along the periphery of the tool. So, the tool reciprocates, rotates and also slightly expands. Lapping is another operation wherein which we completely use the abrasives as free. The abrasive plus you have oil or something to hold the abrasives together, and now you have a lap which does not have any abrasive, which is a tool which is on the top. Then you have something like mud like particles which are abrasive particles. So, now mud is there, then you have a lap, and then this mud is held by some media. So, it is all attached to each other. Now, you try to use the lap and then try to finish the surface. So, you can try to create figure of 8 pattern to generate a flat surface. It is almost like washing a vessel. So, you have a vessel which is a milk vessel cylindrical, or a pressure cooker which is cylindrical. Then you have your hand which is a lap. Then between the cooker or the vessel and the lap you have a brush. This brush has a soap particle. So, that is abrasive. So, where you can move up and down, up and down, up and down and create, and depending upon the abrasive size, a very smooth surface finish can be generated. Super finishing is very similar to that of honing. We use an abrasive stick pressing against the surface and reciprocating the motion. It is same like lapping, but the only difference between super finishing and lapping is the abrasives are held and then you can start moving it. So, reciprocating at a very high frequency, very low amplitude, you try to do a super finishing operation. The strokes are very small, in lap it will be large and it has very high frequency, the pressures are low and it has very small grit size. As compared to that of honing, here lapping is done by a super finishing is done by a stick. So, finally, to recap this lecture, we saw first what is abrasive machining, then we saw grinding, how do you specify a grinding wheel, then what is dressing truing, what are the different types of grinding operations, then we saw various advanced abrasive operations which are used for generating very smooth surface finish. Friends, we have used these references to prepare these slides, and thank you very much.